All right, we are going to graph an absolute value function that is in vertex form. It looks like f of x equals the absolute value of x minus h plus k. That's the vertex form. Now, you're already familiar with h's and k's with the linear functions, and they hold true for the rest of the different kinds of functions too, including absolute values. The h tells you to go left or right. The k tells you to go up or down. There's a minus in the formula here. Now, the vertex form, the vertex is the h and the k. Now, remember, there is a minus in the formula. So if I have the problem absolute value of x plus 2 minus 3, the only way that this could be a plus is if it started out minus a negative 2. When I add the opposite, it becomes positive 2. So my h is literally negative 2, and my k is negative 3. That is my vertex. Now that h tells me that I'm going to have to go, because it is negative 2, I have to go left 2. And it's not what you think. It looks like you would go right 2, but that's not right because of the negative in the formula. So I've got to go left 2, and then the k tells me that I'm going to have to go down 3. All right, and my axis of symmetry will be whatever the h is. So my axis of symmetry is going to be negative 2. That means this divides it into two pieces. Okay, so if I go to negative 2 down 3, here's my vertex. And then since the x doesn't have a number in front of it, it's a 1. That means my slope is 1 all the way up the left side and the right side. Negative 1 this way, positive 1 that way. So there is like the parent graph that has been shifted. And then that just makes it really easy to do that without having to draw a t-chart. Okay. But the second one looks like the first one, except they have a 2 in front of the x. So that changes things, and I am going to need a t-chart. I've already got it drawn out for you. Okay, still know that I've got to go left 2 and down 3, just like before, but the width of it's going to be either more narrow or wider. This is a horizontal shrink, if you'll remember from earlier videos. It's going to be a horizontal shrink because of the 2. And then if they ask you the factor, it's going to be 1 divided by a. So if it is a 2 here, we're going to have 1 over 2. So the factor is 1 over 2. Now, the problem itself is the absolute value of 2x plus 2 minus 3. And if I do the algebra for these, I'll be able to put the green points in the proper places. So let's do this. 2 times negative 2 is negative 4 plus 2. So I've got the absolute value of negative 4 plus 2 minus 3. Well, the absolute value of negative 4 plus 2 is negative 2. And absolute value of negative 2 is 2. So 2 minus 3 is negative 1. I'm going to graph negative 2, negative 1. So left 2, down 1. Have me a point right there. All right. 2 times negative 1 is negative 2. Negative 2 plus 2 is 0. The absolute value of 0 is 0. So I have 0 minus 3, which is negative 3. So I'm going to graph negative 1, negative 3. 1, 2, 3. Let's see, negative 1, 1, 2, 3. All right. Got one there. Okay, 2 times 0 is 0 plus 2. 0 plus 2, absolute value is 2, and 2 minus 3 is negative 1 again. So 0, negative 1, right here. And then 2 times 1 is 2. 2 plus 2 is 4. The absolute value of 4 is 4. 4 minus 3 is 1. I'm graphing 1, 1. Right, 1 up 1. And then 2 times 2 is, oh, that was 2 times 1. I put that on the wrong place, didn't I? Let me change it. 4 minus 3 equals 1. I don't want to start over. This is such a long video, but, oh, wait a minute. No, I'm right. I was right. 2 times 2 is 4, and 4 plus 2 is 6. 6 minus 3 is 3. So I have a point at 2, 3. Right, 2, 1, 2, 3. Okay, so I've got a longer part on this one, this side, than this side. But if you have 2 points, remember you can make a line. Okay, so that one is open, more narrow than normal.